Alrighty, let's talk about the common ion effect. So this is chapter 15, part 2, 1. Now, what is the common ion effect? It's basically another way of restating Le Chatelier's principle when talking about solubility product equilibria. So for example, if we have a solution of barium sulfate that's saturated with some solid at the bottom of the solution, this is the balanced chemical equation, and there's, a KSP value and stuff like that. So if we add barium chloride, what happens? Well, break this substance down into parts. Barium chloride has barium chloride and it has chloride. So barium chloride is a product, so it would cause the reaction to shift left. What we would actually observe is a precipitation forming or more precipitate forms. What about the chloride, you ask? Well, that's not common to the equilibrium. It's a spectator ion, so the chloride doesn't have any influence at all. What would happen if we add sodium sulfate? Sodium sulfate, break it down, is composed of sodium ion, which is a spectator ion, so that's not going to have any influence. And sulfate, well, you can see sulfate over here on the right side of the equation. So this too would cause this reaction to shift left. The precipitation would occur, or there'd be more precipitate occurring. Okay? What would happen if we added H plus to this chemical reaction? You might think, well, nothing. It's not part of the products or the reactants, and it looks to be a spectator ion. But no. Sulfate is a weak base. It can react with H plus to give you bisulfate. Okay. According to, the KB and all that, there's all this stuff involved. We're not doing the math. But basically, H plus decreases the concentration of sulfate because it removes it. It causes it to react to produce something else. So if you remove one of the substances, the reaction will shift towards the decrease. So this would cause it to shift right. And we would expect this precipitate to perhaps dissolve or go away, or the solid would disappear. Okay, so you can add something to increase the concentration of substances, or you could add something that reacts with something else to remove it selectively, or maybe not selectively, from an equilibrium, and that would cause shift left, shift right, and so on. Okay. And also you can influence solubility by temperature as well. We saw that in lab 5 already. Okay, so let's do a problem here. What is the silver ion concentration in a 0.1 molar chloride solution? So we know that the what we want to do is write the KSP reaction out, okay, with the equilibrium arrows and the AQs and stuff. So we've got AgCl. I'm going to do it the long way first, and then I'll show you the short way. So AgCl is this, and then we have silver ion aqueous and chloride ion aqueous. And we want to then set up the ice table. And you always assume you have one chunk or a solid amount. No silver and no chloride is in pure water. This goes down by x, this goes up by x. And we go ahead and solve for X. The KSP for this is equal to the silver ion concentration times the chloride ion concentration. And the KSP for this particular substance is 1.7 times 10 to the minus 10. That's X times X, right? And let's go ahead and do that on our calculator to get a number here for us to admire. In my calculator, there we go. 1.7, 10 to the minus 10, take a square root of that guy. Trying to remember where my, oh yeah, there's my square root button. Okay, so 1.3 times 10 to the minus 5. Okay. Now, this is the solubility of silver chloride in pure silver chloride. I mean in pure water, okay? In pure water. Now, so this is review. I normally review before I start a class or something. Now, what if we wanted to do this for sodium chloride? We would do the same thing, okay? We would write out the equilibrium. We would write Ag plus aqueous chloride. Okay. And we'd set up our initials here. And here's where you would plug in 0.1, okay? Because we are wanting to know what is the solubility of silver ion in 0.1 chloride solution, okay? So this is where you would plug in the chloride ion concentration. All right, this goes down by X, this goes up by X, and we would have all of these things. And we would set up the KSP as before. You plug things in. I'll make it in, yellow so you can see there. Okay, now here we make an assumption so we don't have to use the quadratic formula. We assume X is small. So 0.1 plus X is about equal to 0.1. So you plug this in. Multiply both sides by 10. And you get X. Okay? And if you compare these, you can see how this value here is quite a bit less than this value here. Okay? So the solubility of this silver chloride is diminished quite a bit. Okay, so that's our answer. The question is, what is the silver ion concentration? It'd be 1.7 times 10 to the minus 9th molar. Okay. All right, and then there's a lecture guide problem here. You try this. What is the lead ion concentration in 1.8 molar sodium bromide? Okay.